Section 12.1 was using a table, using a graph. And the table and the graph, both of them, the tables and the graphs, they were meant to build in you an understanding of limits. Like, what's the key word that we remember with limits? Approach. And so when we look at a table, we're not looking at the x equals c value. We're looking at the approach from above and below. Okay, we're looking at the approach from above and below. Remember the jury. What needs to be true for the limit to exist? Aiden, put the phone away. I don't want to take it, but I've already talked to you this week. Above and below need to be equal or be the same or agree, right? And when we are figuring out limits, we're looking at x approaching from below and from above, but where are we looking for the answers? Where are we looking for how to answer the limit problem if they agree? We're looking as x approaches from below and above c, but where do we look for answers? No, that's the by hand stuff. Just in general, thinking back section 12.1 in the tables. If x is approaching, let's say 1.9, 1.99, 1.999, 2.1, 2.01, 2.001, x is approaching what? 1.9, 2.01. It's approaching 2. X is approaching 2, but 2 is not my answer. That's the limit as x approaches 2 of f of x. The limit as x approaches 2 of f of x is the problem. Where do I find answers? In the y's. That's what I was looking for, y values. So as x is approaching, we look at the y's and say, what are the y's doing? Are they in agreement or are they not? Kiddos, just because, or I should say if we have a hole, does that mean the limit doesn't exist? No. What needs to be true for the limit not to exist? This limit totally exists because I'm not looking at the hole, I'm looking at the approach. And do the approaches agree? The answer is yes. What would need to happen for the limit to not exist? Good. Going to two different locations, the car from below, the car from above, if they're headed two different places, right? What if we had that funny thing called a vertical asymptote? What would it take for the limit to actually not exist? Not just technically, but actually not exist. Yeah. One of them's going up, one of them's going down. However, as long as they disagree, the limit doesn't exist. So if I were to ever see this happening? But good, they agree, so I could say the limit equals positive infinity. And what about if they're both going down? But if they don't agree, the limit does not exist. Good. So that was all to do with tables and charts and all that jazz. Section 12.1 ended with the properties, which were super, super easy. Saw an example yesterday of the clues that the limit of f is this and limit of g is that. So what's f plus g? Just add them. F over g, just divide them. But then we also ended section 12.1 with this guy. What's this guy talking about? Just plug it in. Just plug what in? Just plug this in. Take this guy, plug it into f, and say, does he work? What kinds of functions are direct substitution enough to solve? Well-behaved. Well-behaved. So it's not a hole, it's not a vertical asymptote, there's no over 0, so we're good, we're done. But the one thing that you're going to see happening over and over and over and over again in section 12.2 is just plugging in doesn't work from the beginning. And so if just plugging in, this kind of looks like a percent sign. I'm so sorry. If you're thinking that's percent, it's not. It's not percent. It's 0 over 0. And what happens if we get 0 over 0 again? And what we saw yesterday was, for the next step, if plugging in gets you 0 over 0, keep going. If you have polynomial tops and bottoms, if you have polynomial numerator and denominators, then we're going to try factoring or polynomial division. So we got one where it's like, factoring, we can do that, sweet. And the top and bottom had matching factors, shared factors. We were able to remove it by reducing. And then we plugged in, dun, 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 and we got our answer of -5. This one could have factored if you knew how to factor this difference of squares. It was totally possible to factor, to find the shared one, to get rid of him, to remove the whole, and then plug in. But what's going on that side, guys? All the work if you didn't know how to factor. You could do polynomial division, and after you do polynomial division, you would see how many times this guy goes into that guy. That's the quotient. And then we can take the limit of that quotient and get to the place that we need to end up at, which was 4 in this example. Then we did another one where it was like, ooh, a lot of you would have had a lot of struggles factoring that guy. But polynomial division didn't end up being too bad. And so polynomial division ended up getting all the way down to this guy going in evenly, x squared minus 3x plus 9 times. Now, hold on. I think your notes didn't finish this because I didn't even finish it. How do we finish this problem now that we've done the polynomial division, gotten rid of the x plus 3, and gotten to here? Yeah. Well, I guess we could factor, but we don't need to, do we? Just plug in, yeah. Take the negative 3, square it. Take the negative 3, plug in times negative 3, and then add the 9. Wait. Why did I stop writing limit? I thought you weren't allowed to. You're actually solving it. You have done the process of taking the limit. So when we plug in, the limit stops being written because you've actually taken the limit. It didn't work, though. Keep going. So we had to come back and still keep trying to take the limit, but we were able to this time, so then we're done after we simplify. So 9 plus 9 plus 9 ends up being 27. Polynomial division made all the difference. So that's step number 1. Well, technically step number 2. First, we try to do direct substitution. It works. Yay, we're done. It doesn't work. Are there polynomials? If so, factor or divide. But what about if there are square roots or any sort of radicals? Square roots, cubed roots, fourth roots. And as you guys get to that example that you see, you might realize, I don't want to factor that guy. I don't even know how. I don't want to divide that guy. I don't even know how. Now, just to make this match period 2, just because we didn't have the notes in front of us to begin with, didn't realize the computer wasn't going to be working for 2 hours. We did that example, so I'm going to go ahead and write this example. It's super similar. That way, any of the period 2 people that were gone, or even the ones who maybe need to come back and still take their notes because they just listened during class, this way it'll be the same example. Now, technically, you shouldn't be thinking about factoring yet anyway, because the very, 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 very first thing you should be doing is plugging in. So plug in. Plug and chug. As you guys do that, let me write quick summaries of what we've done so far, because I think it was helpful for the class to be able to visualize this morning when I was writing on the board. So far we've talked about direct substitution for well-behaved functions. It works great because all we have to do is find this little C guy and plug him in, and we'll be done. Step number 2, and I think this is a vocab term in your homework, is the dividing out method. Which will be great for any sort of polynomial on top and bottom, when you just have polynomials on top and on bottom. And dividing out, we'll be doing factoring if it's possible, which for some of you, you're able to factor better than others. You might be able to factor more than others. But you can always go to long division or polynomial division also in order to divide out. Let's see, the example that we just did was the limit as x goes to 3 of x cubed plus 27 Oh, negative 3. All over x plus 3. And we got 0 over 0. We had to keep going. We had to do some division because not most of you would know how to factor that top guy, even though there is a way. You end up with x squared minus 6x plus 9. Oh, sorry. Is that right? No, 3x. Thank you, thank you, thank you. That was good? Okay. And then we were able to plug in chug. And ultimately, what that did, that polynomial division, is it ultimately said how many times x plus 3 went in. So technically, by doing long division, you were able to cancel that guy out, which is how we got here. Then we just plugged and chugged. So negative 3 squared minus 3 times negative 3 plus 9 ended up being 27. Dun, 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 dun. Now we're on number 3. And this is the one that you guys are writing down. And number 3 is all about, the big fancy word is rationalizing. But what does it say underneath rationalizing, guys? Radicals are the types of functions. I'm going to put that in blue. If we have radicals with zeros over zeros, remember all of section 12.2 is like, oh, we have some non-well-behaved functions or some functions that aren't behaved where we're trying to take the limit. So we have this 0 over 0. We're trying to figure out how to keep going or what are the different ways of keeping going. Polynomial top bottoms, try dividing out. Radicals, ugh, we don't want to try to factor out. Instead, what does it say underneath? Yeah, multiply by the conjugate. Okay, and we have an example right there. And maybe you guys can tell why we're not going to factor. There's a square root. How do we factor a square root? We don't. Wait, why are we even thinking about factoring? Plug in, that's what you guys already did, but what happened when you plugged in? Square root of 9 is 3. 3 minus 3 is 0. 3 minus 3 is 0. What are you supposed to write after 0 over 0? Keep going. Now, if we have to keep going, that means the plugging in didn't work. We have to come back here and rewrite the limit, yeah? So we're going to keep the square root of x plus 6, because I don't know how to factor this guy. We're going to keep the minus 3. We're going to keep the x minus 3, but we're going to multiply by, okay, here's what multiplying by the conjugate means. We take the piece with the square root that's stuck right now. I don't mind this guy. This guy looks a lot like this guy that was able to be canceled or reduced, I should say, with factoring or division up above. I don't mind the denominator. He's great. The numerator is a mess, though, because I don't know how to simplify this guy. So what we're going to do is take that numerator, take whatever piece has the square root, and the conjugate means, we've used it a couple times this year, keep it the exact same except for the sign in between the radical and the non-radical. Flip that puppy. Flip them. What you do on top, do on bottom. We got to multiply by 1 creatively. Now, we probably haven't fixed the problem all at once, all in this one step of putting multiplication, but let's see what happens when we do multiply. Now, here's something to remember, and we did a quick little reminder in period 2, and I think it helped. Let's make this a little bit bigger. I reminded real quick that conjugates with their originals are always going to make a difference of squares. If you guys remember difference of squares from algebra, if we were to FOIL, any difference of squares, no matter how messy, that's a difference of squares even though it's messy. You always, always, always get to cancel out the outer plus the inner. And you always, always, always end up at a squared minus b squared. That's not killing a puppy. That's not doing illegal math. A squared minus b squared is what will always happen with differences of squares. So we can go ahead and multiply these guys and say, hey, difference of squares, sweet. First will be squared, a squared. Square root of a squared is x plus 6. Remember, the square root goes away. Then minus b squared. And then 3 squared will be 9. The only reason I'm able to make that jump is because it's a difference of squares. Now on the bottom, I don't mind that x minus 3. Remember, I'm hoping he cancels out like the x plus 3 did in that example. So I'm going to go ahead and keep the x minus 3 right where he is, but I just have to read who's next to him, which is the square root of x plus 6 plus 3. What do you guys see? Can we simplify anything? Yeah. X plus 6 minus 9. I mean, I can distribute like a little positive 1. X plus 6 minus 9. Isn't that x minus 3? Booyah. Now, some of you, as you get better at this, you're going to stop writing the limit. But remember, we can't stop writing him until we've taken it. Solving, solving, solving. But what do you guys notice can happen now? We can reduce. What happens when you reduce top bottom? You get an understood 1, right? What can I do now that the x minus 3, now that the little piece that made a 0 to begin with is gone? What do you think? Plug it in, plug it in. Why am I going to stop rewriting the limit? I'm taking it. I'm plugging in 3 because that's my special x value that's being approached. Square root of 9 is 3, right? 3 plus 3 is 6. Dun, 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 dun. That's going to work every time. So it's your turn to practice. As I do a quick little summary up here for us to be able to refer to for the rest of class, I want you guys to see if you can repeat the process. And why are we repeating the process? Well, because from the very get-go, what happens when you first start trying to solve? So keep going. How? It has a radical. Multiply by the what? Kind of the negative. By the opposite. It's not going to be minus, though. It's going to be plus. By the conjugate. All right, check in with your groups if you haven't yet. Have you guys started the same way? Did you choose the same conjugates? Just see if they started the same way. If you need to finish, take a little more time. You guys have this in your notes. It's the exact same example. I'm just writing it so that we can refer back to it together if it matches up with what we're doing on the board. My turn? Can I play? Can't factor it, can't do long divisions. I better just leave it as is, but I multiply by the conjugate. And who is the conjugate of this guy? Square root of x plus 4 plus 2. And what I do on top, I must multiply by 1 creatively. Do on the bottom. Some people try to go crazy and like do the same and just what you do on top, do on the bottom. The conjugate of the radical part has to be top and bottom. What did this form again? Who are these two guys? They're differences of squares. Some of you are just going straight to the multiplication. I totally get you. Yeah, there's a shortcut to multiplying. I have it up on the board. You have it in your notes. Differences of squares. So we end up with, you guys are right, x plus 4 minus 4, right? You could put little parentheses, but if you distribute the 1, it really is just x plus 4 minus 4. On the bottom, leave the x out. Don't go distributing him because I want to cancel him out. I want to cancel him out. This denominator, it's 0. That's a problem, but it's also 0 on top, so I'm hoping I can cancel, which I can do with polynomials. I can do after I multiply by the conjugate eventually with radicals. I just need to leave the x there for a little bit longer and see what happens. And what does happen? What's plus 4 minus 4? 0. So don't you end up with x over? And some of you already went further because you're like, wait, there's an x on top and bottom. So you can just simplify him. What's left? 1. And then why am I going to stop writing limit? Because I'm going to plug in and be done. So 1 over the square root of 0 plus 4 plus 2. Square root of 4 is 2, and 2 plus 2 is? Did you get it? It's all right? Step 1, plug in. It's nice, you're done. Step 2, you plug in, it's not nice. There are polynomials. Okay, so then do division, either factoring or long division. Step 3, they're not polynomials, and I still have 0 over 0. Okay, fine. Are there radicals? If so, multiply by the conjugate. Hang in there, and they will simplify again. Step 4, 0 over 0, keep going, and they're not polynomials, top and bottom, and they don't have a radical. Now they have complex fractions. Now they have complex fractions. Well, number 4 just says, simplify it. Simplify what? Simplify the problem. Simplify the complex fraction. So in the step is the problem. Nice thing is, I've tried to help you guys with these ever since the beginning of the year. So let's see if we can finally figure it out. If you guys remember, you get everything written down except for the blank, maybe start trying to simplify. Trevor's the only one gone. Who was gone for French yesterday? Were you guys gone for French? No, okay. Just Trevor's been gone. Do you guys remember my trick for simplifying complex fractions? The common stuck denominators. The common stuck denominators. Multiply the stuck and multiply top and bottom, the conjugate. What you do on top, you multiply on top, it has to be on bottom also. We have to be multiplying by 1 creatively, or else we change the value, and then, well, we change the problem. It's not even going to be right. Unless we make some weird mistake and it ends up being right by some miracle. But that's not God giving us a miracle on a homework problem that we started off wrong. Maybe we should pray for different miracles than that. So, who's the stuck denominator? Oh, wait. This would be a great test problem for me to give and then make it like a nice, well-behaved one, because it looks horrible. What if I had x approaching 1? It'd be fine. Plug it in. You're done. So just be careful. Always, always, always start by plugging in. So what happens when you plug in? 1 over 1 is 1. 1 minus 1. Oh. Now, some of you are like, oh, they've all been 0 over 0. I know. What's section 12.2 supposed to be about? Of course they've all been 0 over 0. That's what the whole section is, how to deal with 0 over 0. But on the quiz on Friday, could I give you some nice plug-in ones? So plug in first, because maybe it's a nice one and you're done. Always plug in first. And even if it's a weird one, if you get to 0 over 0, keep going. I'm like, okay, I'll give them at least a point because I know what they're supposed to be doing, even if you go way off track. Okay, so now, all right, well, plugging in didn't work. Okay, rewrite the limit. We're not done. Just like with radicals, it's kind of like, I don't know what to do looking at that. Okay, so let's multiply by something to change it up. What are we going to multiply by? Right here, the common stuck denominator. Who's stuck? X plus 1. He's the one messing me up. So multiply by x plus 1 on top and on bottom. Put parentheses. Everything's safe because you know how everything is grouped. Now, if you remember how to do this, on bottom, it's really easy. Because on bottom, just like the other ones, just leave the x. We're really hoping he cancels out like he's canceled out for the factoring long division-y one. If it's factored, we see it canceled out. If it's long division, it just like poof, disappears. With the conjugate, we see him reduce out or cancel out, technically reduce. We want that to happen here also, but we have to do some simplifying first. So the bottom, just rewrite. Keep writing the limit because I haven't solved them yet. Are you rewriting the limit? Please do. Okay, this guy needs to distribute to him and to this one. So hold on, first things first, x plus 1 over x plus 1 will be 1. Minus 1 times. Why is it super important that you put parentheses? You have to distribute the negative because you're subtracting the whole thing. Does that make sense? Okay, no killing seals today, or tomorrow, or the next day. Distribute the negative. You guys know what I mean by that, right? It's a negative 1, and I say, okay, times a negative, cool, and times a negative. So what happens as I have 1 minus x minus 1? Who cancels? Yep. Who's left? Ooh. What would negative x over x reduce to be? I can reduce these, right? But what's still there? A negative sign. So be careful, not a negative sign like sign as in trig. A negative that needs to be with a 1. Does that make sense, guys? So I've been solving. I've been wanting to take the limit and not quite been able, but as soon as I get to reduce that guy away, dun dun dun, plug it in. The limit is gone. Why? Because I just found it. Is that okay? Want to see if you can do it? Try him. You got it. You got it. You got it. You got it. There are two okay, well, yeah, that's whoa. But you got the problem on the board. There are just 2 stuck denominators, but that multiply by both of them. Ready? Go. Shh, focus. Would have been super fun if 1, but I didn't. So guess what this ends up being? Would have been nice though, and maybe on the quiz I'll have a nasty looking one that's really nice to solve. If you see anybody stuck in your group, just check in on them and be like, hey, do you know what you're multiplying by? Multiply by both the stuck denominators, both of them. Talk louder for Anna. Isn't that what you're asking?
Everybody whisper. I can barely hear them. Everybody whisper.
Okay, shush, be productive. Silly goofs. Anna, you see your 2 stuck guys, right?
Yes.
Cool. So multiply top and bottom by those stuck guys. Uh-huh. Both of them, top and bottom. Because like in this example, if we can just find that little stuck denominator, multiply top and bottom, things get a lot easier. Direct substitution didn't work right away, so we got to do something else. Just like the radical, this complex fraction would be way too hard just to try to do in our head unless you get really good at my trick. Then you can start doing this whole process in your head, which is kind of nice. Takes some practice, though. Did you guys see him? Are we okay? Okay, now the question is, can you multiply correctly? The whole thing needs to distribute twice, right? The first time, times 1, well, it's all still there. The second time, only the plus 4 1 cancels, and I have the plus 1 1 remaining. And just a couple of you are like, hey, there's shared x plus 1. Good idea. On bottom, it needs to distribute. The x plus 1 1 cancels, and I have 2 and x plus 4 remaining. And the second distribution, oh, I have all of them. I haven't crossed anything out, so I wouldn't go trying to plug in right now. Remember, we're still trying to cross something out. Whether we do the dividing out method, do the, or whether we do a simplifying complex, that's really messy, fraction method. We're trying to cancel out the whole. But pause. What did I say? X plus 1. So if I pull out an x plus 1, I get x plus 4 minus 4. Shared on bottom. X plus 4, and then go 2 x plus 1. Okay, wait, I have to distribute a little bit, right? Just have x plus 1 times x all over x plus 4 times, okay, hold on. This will be 2 minus 2. Oh, the 2's cancel. And then I get negative 2x from, you see them? Doesn't the x get to reduce with the other x? And why stop rewriting the limit? I can plug it in. Plug it in. Anybody beat me to negative 1/8? Nice. You sound surprised. You changed it to make it wrong? You know what's crazy? Do you guys remember yesterday in section 12.1, there was that really nasty one with the really nasty decimal of negative 0.0625? Where is it? And it was really hard to figure out what it was approaching. Check it. Who is this guy? 0 over 0, keep going. What camp does he fall under? He's a complex fraction. How could you have figured out negative 1/16 without doing the nasty decimal in the table that I don't know? The process we just did. What would you multiply top and bottom by? X plus 2 times 4. I would probably multiply both of those. Conjugates are for radicals, and factoring division for polynomials. Oh, wait, there's a number 5. Number 5 is, remember you learned how to do tables and graphs, which can be even of really disgusting and nasty functions. If you're totally stuck, could you go to a table and try to figure out what seems to be happening? Yes, you could, but to be honest, sometimes the table might take longer than just doing it by hand. And so what are we seeing in 12.2? Doing it by hand. What was number? Okay, fine, if you're totally stuck and it's an even and you don't know what the answer is, maybe plug it in the table and see if you can figure out what it is and if it's a nice function or not. What's that? Wait, we already did this page. You guys remember how I had to write it all? Why is it in this section? I have no idea. Poor little guy, got in the wrong place. There. 12.2 tomorrow. Sound good? Dun, dun, dun. 30 seconds of resting and relaxing. You're welcome. Then lunch. If you guys want to write down homework, there it is if you haven't started yet. People who did start, did you get stuck anywhere?